resistance and then resistivity. R equal to V over I. This definition. Not Ohm's law, it's definition. V is the potential difference between those two ends, and I is the current, so the conductor. Metric system unit of resistance 1 ohm equal to 1 volt of ampere. Volt or ampere. Symbol of a resistor, you could write this, and sometimes like this one, and so on. Resistivity rho is defined as E over J. E is electric field, J is the charge density. At the same point. Metric system unit for resistivity rho is, this is E is volt over meter. J is ampere with meter squared. So we put them together, we get volt over ampere, meter is ohm dot meter. This is resistivity. We have a right form, vector form, E equal to rho J. This is for isotopic material. Conductivity defined sigma 1 over rho. This is definition. We know this one, we know conductivity. Metric system unit for the conductivity sigma is this over. You get it. This is ohm dot meter reverse. We call it S over meter. Calculating resistance from resistivity. We have a conductor. A cross area is A. And the length is L. This V is the voltage difference, potential difference. Okay, the I current over this one. So with the E equal to V over L. Okay, and the J is I over A. And the rho equal to E over J. We put the E inside, J inside, and we get the rho equal to V over I, A, L. You can see, V over R is, I is R. So this is R, A, L. Okay. And then R equal to rho times L over A. We can imagine the longer the conductor, the larger the R. The larger the area, so the less the resistance. We look at that resistivity. The silver copper about 10 to the minus 8. Okay, and you see the glass, the inductor 10 to 10 to the 14. Okay? And we have between them, we have a semiconductor. Okay, the difference is all these temperature coefficient of resistivity is positive, but semiconductor is negative. Negative means the temperature increase, the resistivity decrease. Resistivity variation with temperature. Look at this one. The temperature goes up, the resistivity goes up. Okay, this is room temperature. It changes to temperature. Delta rho equal to alpha rho 0 delta T. That's the temperature change, proportional to temperature change, proportional original rho 0, and proportional coefficient alpha. Okay. This alpha we call the temperature coefficient of resistivity. And it's a temperature function. It's not linear to delta T actually. When we do more accurately accept this word, we have second IT, delta T squared, delta T cubed, and so on. But these are beta, gamma are very small.
This iron wire in series with this small lamp will be used to demonstrate the effect of heating on resistance. A current is sent through the wire and the bulb, which lights brightly. When a gas flame is lit beneath the wire, current through the wire drops and the bulb dims.
This coil of copper wire in series with this lamp will be used to show the effect of cooling on electrical resistance. We'll run a small current through the coil and the lamp, which lights dimly. When the coil is cooled by dipping it into liquid nitrogen, the brightness of the bulb increases dramatically.
Sample. Sample. A rectangular block of iron has dimension 1.2 centimeter, 1.2 centimeter times 15 centimeter. A potential difference is to be applied to the block between the parallel sides, and in such a way that those sides are equal potential surface, as in the figure. This is equal potential. Okay. What is the resistance of the block if the two parallel sides are 1 square and with diameter 1.2 centimeter times 10 centimeter? This one square. Two rectangular sides with diameter 1.2 and 15 centimeter. We look from. So the answer, area. The area 1.2 times 1. We have to use the standard unit meter. So this is centimeter 10 to the minus 2. 10 to the minus 2. Okay, this is area. Okay, and the length is 15. You have to use the meter times minus 2 meter. Okay, so we put the R1 equal to rho L1 of L1. We know the rho. Okay, this is a standard copper, right? And then you have L1, you have A1, you get R1. Two. The area is 1.2 times 10 to the minus 2 meter, and the 15 centimeters, 15 times 10 to the minus 2 meter. This is area. Okay, the length becomes 1.2 10 to the minus 2 meter, and we find R2. This one is much different from previous, much lower because the area different.